Greetings and welcome to the continuation of the series of equations and inequalities in one variable. Lesson 2.4, Linear Equalities in One Variable. When we're talking about a linear equality in one variable, I suppose we need to describe what a linear inequality is. And it can be written in the form of ax plus b with some inequality symbol, and for instance, a less than symbol, c, where a, b, and c are constants, and a does not equal 0. Now the inequality symbol can be replaced by any inequality symbol. So it could be less than, greater than, less than or equal to, greater than or equal to. A couple examples of linear inequalities would be something like 3x minus 2 is greater than or equal to 7. Negative 5y is less than 25, or even 3 times x minus 4 is greater than 2x. Now they're not in the standard form, the 3 times x minus 4 is greater than 2x, but we could put it in the standard form, ax plus b is less than c, if we needed to. Now we have a cool little property that we can utilize, and for the addition property for inequalities, for any algebraic expressions a, b, and c, if a is less than b, then a plus c will be less than b plus c, meaning that if we add the same value to each side, it's not going to change the inequality. Again, this inequality can be less than, greater than or equal to, less than or equal to. Let's work with an example and try and solve, and we'll also graph the solution. 3x plus 3 is less than 2x minus 1. Now, we're going to get all the x's onto one side and our constant to the other, just like if it was an equality. But we have to evaluate it different once we get the solution. So I'm going to subtract 2x from the right-hand side, subtract 2x from the left-hand side, giving us x plus 3 is less than negative 1. Now I'm going to subtract 3 from the left-hand side, subtract 3 from the right-hand side. That will give me x is less than negative 4. Now what does that mean? It means that as long as I choose an x value of less than a negative 4, this statement will hold, the original statement will hold true. So what does that look like on a number line? So here I've just drawn a number line, and because I don't include negative 4, I leave it as an open circle, and then it's everything to the left of that. If you ever get confused, the cool part about it is if you write your variable on the left-hand side and your constants to the right, the arrow will tell you which to point. It will point in the correct, it will point in the direction as to what your arrow should point on your number line. Okay. Now that's one way of writing it on a number line. In set notation, it would be x, and this line means such that x is less than negative 4. That's a whole entire set of x's. If I want to write it as an interval notation, instead of an open circle, I'm going to use an open parenthesis. So everything else remains the same, but I'm going to have an open parenthesis. And then in interval notation means that I take all the numbers that it can be. Now since I'm going to the left, that means I can take it all the way out to negative infinity. The problem with negative infinity is I can't include negative infinity in my answer because, let's face it, negative infinity is just it's a concept, it's not a number, and therefore I can't include a constant when I need a number. So we leave it in open parenthesis. And then since negative 4 is not included, we also leave that as a parenthesis. And this is called an interval notation. So let's talk about interval notation and actually graphing these interval notations. Now you've seen inequality notation. That's going to be something like x is less than 2. Interval notation means that what numbers fit in that interval. And since it's everything less than 2, we're going to go all the way down to negative infinity. But negative infinity is not a number. It is a concept. We can never include it. So it's always going to be a parenthesis. Anything touching the infinity or negative infinity will always be a parenthesis. Comma 2. So our interval goes from all the way negative infinity all the way to 2, but it doesn't include 2, so it's a parenthesis at the end there. And when we're graphing using parentheses or brackets, we're going to use the same type of notation. So it's a parenthesis on 2, and then pointing all the way to the left. So it includes everything less than 2. In dot notation, we would have an open dot on 2 because we're not including it, and then pointing everything to the left. Let's try another one. X is less than or equal to 2. This time we have some equality in there. Again, it means everything less than, so I can go all the way down to negative infinity. So it's going to be parenthesis, negative infinity, comma 2 is my interval. But since we're including 2, it's going to be a square bracket. When I'm graphing with parentheses and brackets, I'm going to have a bracket on 2 because I'm including 2, and then pointing everything to the left. If this was dot notation, then it would be a closed dot on 2 and then pointing everything to the left. X is greater than or equal to negative 3. So if we think about it, if it's greater than or equal to negative 3, then we can't go lower than a negative 3. That is our bottommost boundary. That's our left boundary. But we are including it because we have some equality here. So we're going to, in interval notation, we're going to use a bracket, negative 3, comma, all the way up to positive infinity, and then parenthesis. When we're graphing it, we're going to put the bracket on negative 3 because we're including it, and then pointing everything to the right. If this was dot notation, it would be a closed dot on negative 3 and pointing everything to the right. X is greater than negative 3. Now we're not including negative 3, so it's going to be a parenthesis in the interval notation. So it's parenthesis negative 3 all the way up to positive infinity, and then parenthesis. Likewise, with the graphing, we're going to use a parenthesis and not a bracket because we're not including it, and pointing it to the right. If it was dot notation, it would be an open circle and pointing to the right. Let's consider some inequalities with actual numbers. 3 is less than 5, negative 3 is less than 5, negative 5 is less than negative 3. They are all true statements as they are written right now. Now let's multiply each with a positive number, and we'll just pick 4 for simplicity. And what I mean by multiply each, I have to multiply both the left-hand side and the right-hand side. So if I do that to each of the inequalities, 4 times 3 is less than 4 times 5, well that would be 12 is less than 20, which is still a true statement. 4 times negative 3 is negative 12. 4 times 5 is 20. Well, negative 12 is still less than 20. 4 times negative 5 is negative 20. And 4 times negative 3 is negative 12. Negative 20 is less than negative 12. So all of these, if I multiply by a positive number to both sides, still hold true. Now let's consider multiplying by a negative number, and we'll just choose negative 4 for ease. Okay. Negative 4 times 3 is negative 12. Negative 4 times 5 is negative 20. Is negative 12 less than negative 20? Nope. Negative 4 times negative 3 is 12. Negative 4 times 5 is negative 20. Is 12 less than negative 20? Nope. Negative 4 times negative 5 is 20, and negative 4 times negative 3 is 12. Is 20 less than 12? No. And in fact, when we multiply a negative number to all of these, they are false, we actually must flip the inequality symbol, flip it, to make it true. Well, there's a property for that, the multiplication property for inequalities. Let's say A, B, and C represent any algebraic expression, and if we say A is less than B, then A times C is less than B if C is a positive number, meaning C is greater than 0. Or A times C is greater than B times C if C is a negative number. In essence, if we multiply by a negative number to both sides, we must reverse the direction of the inequality symbol. Let's try an example. Negative 2y minus 3 is less than or equal to 7. Well, I'm going to treat it like this inequality symbol is just an equal symbol for now. Okay. I'm going to add 3 to both sides. That gives me negative 2y is less than or equal to 10. But here's the problem. I am going to divide by a negative 2, or multiply by its reciprocal, which is the same thing. Multiplying by a negative reciprocal is the same thing as dividing by that number. So when I divide by negative 2, I must reverse the direction of the inequality symbol. Y is greater than or equal to negative 5. Now I know what y is. I can plot it. In set notation, y such that y is greater than or equal to negative 5. In interval graphing notation, since I'm including negative 5, I am a bracket and then pointing to the right. And in interval notation, it is a bracket, negative 5, comma, infinity, parenthesis. Let's try one a little bit more complex. 3 times 2x minus 4 minus 7x is less than or equal to negative 3x. Okay. First step I'm going to do is I'm going to distribute 3 to the 2x as well as the negative 4, giving me 6x minus 12 minus 7x is less than or equal to negative 3x. Okay. On the left-hand side, I've got some x's, so I'm going to combine like terms. I get negative 1x plus 12 is less than or equal to negative 3x. Now at this point, I have, on the left-hand side, I have x's and constants. On the right-hand side, I have x's. For me, this is just for me, I like my variables to be on the left-hand side. So I'm going to move my negative 3x over to the left and my constant of the negative 12 over to the right. I'm going to add 3x, giving me 2x minus 12 is less than or equal to 0. Add 12, 2x is greater than or equal to 12. Divide by 2 for each side. X is greater than or equal to 6. Now, if I would have moved the negative 1x over to the right, then I would have had to divide by a negative number. And when I divided by a negative number, I would have had to reverse the sign, and I still would have gotten the same answer. For me, it's just easier to always bring the variables to the left because ultimately I'm going to read it from the left. X is less than or equal to 6. In set notation, x such a x is less than or equal to 6. Graph notation, I have a bracket because I'm including 6. Bracket, then pointing everything to the left. In interval notation, since it's pointing everything to the left, it means it's going down to negative infinity, so it's parentheses, negative infinity, comma, 6, bracket. Let's change gears just slightly and talk about compound inequalities. There are two things that we're going to study about compound inequalities: unions and intersections. So let me talk about unions just for a moment. If we have two sets, and I'll just call them A and B, it's the set of the elements that are in either A or B. Let's see an example. Let's say that set A contains 1, 3, 5, 7, 9, 11, and 13. Just a whole bunch of odd numbers. And set B contains 1, 2, 3, 4, 5. Then the union of A and B would be the set 1, because they both have a 1, 2, because B has 2, 3, because both of them have 3, 4, that comes from B, 5, both of them have 5, 7, 9, 11, and 13, all from set A. Now the intersection of two sets, A and B, it's the set of elements that are in both A and B. So the intersection of A and B for our set A, which is 1, 3, 5, 7, 9, 11, and 13, and set B, which is 1, 2, 3, 4, 5, are going to be those values that are in both A and B. So 1, 3, and 5. 2 is not in A, so it won't be in the intersection. 4 is not in A, so that won't be in the intersection. 7, 9, 11, and 13 out of A will not be in the intersection because they're also not in B. Now we should note that there are two very key words here. For union, the word is going to be or, and for intersection, the word will be and. Let's see an example. We're going to graph the set x such that x is less than or equal to -2 or x is greater than 3. Now if you want to think about this, we can graph them separately. X is less than or equal to -2. That's going to be a closed bracket pointing to the left. X is greater than 3 is going to be a parenthesis on 3 pointing to the right. And since it's an or, either one of these can be true. Therefore, the union of x is less than or equal to 2 or x is greater than 3 is going to be the closed bracket on -2 pointing to the left, as well as the parenthesis, open parenthesis on 3 pointing to the right. In interval notation, it's going to be open parenthesis, -infinity, comma, -2 bracket with a U standing for union, parenthesis 3, comma, infinity, parenthesis. Okay? So the U will stand for union. So let's try another one. Let's graph the set of x such that x is greater than -1 and x is less than 2. And is our key word here, therefore it's the intersection. Okay? I'm going to graph them separately. X is greater than -1, meaning I have an open parenthesis on -1 and pointing to the right. X is less than 2, open parenthesis on 2, pointing everything to the left. Now where they both happen is going to be the parenthesis 1 heading to the right but stopping at 2, close parenthesis. It's everything in between -1 and 2. And in fact, interval notation, it almost looks exactly like that. Parenthesis, -1, comma, 2, parenthesis. This is an open interval, meaning that both sides of this interval have parentheses. Now, we can also write something similar to this, like -3 is less than or equal to x, and x is less than or equal to 4. We can write this squished together. -3 is less than or equal to x is less than or equal to 4. This is called continued inequality. And how we would write it, graph it, would be two closed brackets, because I have equality on both, and it's everything in between -3 and 4. So as we're writing it in interval notation, bracket, -3, comma, 4, bracket, this is a closed interval. It is closed on both sides because we're using brackets on each side. Let's explore the interval notation in graphing again. So let's say for compound inequalities, we have -3 is less than x is less than 2. In interval notation, since neither one of these include any equality, they're going to be parentheses. And since x is right in the middle, excuse me, since x is right in the middle, you can think of it as the boundaries are -3 and 2. So in interval notation, it's going to be parenthesis, -3, 2, parenthesis. Graphing is very similar. So it's going to be a parenthesis at -3, a line all the way to 2, and a closed parenthesis. In an open closed dot situation, since I don't have equality, it's going to be an open dot on -3, an open dot on 2, and then everything in between. -3 is less than x, less than or equal to x, is less than or equal to 2. This time they both have equality, so it's going to be brackets for our interval notation. Bracket -3, 2, bracket. In our graph, we would use brackets instead of parentheses. Bracket on the -3, bracket on the 2, everything in between. If this was dot notation, it would be a closed dot on -3, a closed dot on 2, and everything in between. -3 is less than or equal to x is less than 2. With the 2, there is no inclusion of the 2, so it will be a parenthesis next to the 2, whereas next to the -3, we're including -3, so it will be a bracket. So our interval notation is bracket, -3, 2, parenthesis. Likewise with the graph, there's going to be a bracket on the -3, parenthesis on the 2, and we're going to draw a line, everything in between. If this was open and closed dot notation, closed dot on -3 because we're including it, open dot on 2 because we're not, and everything in between. And the fourth way of writing this, it's -3 is less than x is less than or equal to 2. Then the bracket's going to be on the 2 because we're including it. So parenthesis, -3, 2, bracket. Very similar in the way we're graphing it. Parenthesis on the -3, a bracket on the 2, and then everything in between. In open and closed dot notation, that's going to be an open dot on -3, closed dot on 2, and then everything in between. All right, so let's solve one of these compound inequalities, and we'll also graph it as well. So I have -3 is less than or equal to 2x minus 5 is less than or equal to 3. There are two methods to solve this. The first method, I'm just going to say we're going to break it apart. We're going to break it apart into two equations. The first one will be 3 is less than or equal to 2x minus 5. And our second equation will be 2x minus 5 is less than or equal to 3. So you can literally write them separately, solve them separately, and then come up with your two, if possible. If there are two solutions, then there'll be two solutions. All right. First one. Add 5 to both sides. Now I have -2. That should be a positive. What am I thinking? That's a positive. A positive 2 is less than or equal to 2. Divide by 2. That should be a positive 1. I goofed. We won't tell anybody. Okay, so I have a positive 1 is less than or equal to x. Now if I was writing this left to right, I would just flip everything around. X is greater than or equal to 1. Okay. On the other side, I'm going to add 5. Add 5, 2x is less than or equal to 8. Divide by 2, divide by 2. X is less than or equal to 4. So, one is less than or equal to x is less than or equal to 4. When I bring those two together, it's going to bring this squished notation, right? Okay, that's one way of solving this. Let's see if I made my mistake twice. The other method is to keep it together. Okay? If I keep it together, I'm just going to do my operations on the left, middle, and right at the same time. So I want to add 5 to the middle, add 5 to the left, add 5 to the right. That's going to give me, I did the same mistake twice. 2 is less than or equal to 2x is less than or equal to 8. Divide everybody by 2, the left, the middle, and the right, all by 2. That's going to get me 1 is less than or equal to x is less than or equal to 4. The nice thing about this is that it's already written with the x in the middle. And now, just going to fix my 1's there. If I'm going to graph it, since they both have equality, I'm going to use a bracket and everything in between. And for interval notation, it's bracket 1 commas 4, bracket. Okay, so let's try another compound inequality, this time working with OR. Now the good part about OR is I'm just going to work with them as is, like they're totally separate problems. I'm going to solve the left one, I'm going to solve the right one, and then ultimately I'm going to see what x possibly could be. Okay. For the left one, I'm going to subtract 7, that gives me 3t is less than or equal to negative 11. Divide both sides by 3. I get t is less than or equal to negative 11 thirds. For the right equation, again, I'm going to subtract 7. Now I have 3t is greater than or equal to negative 3. Divide by 3, divide by 3. X is greater than or equal to 1. Here's my set notation. T such that t is less than or equal to negative 11 thirds, or, because my problem was an or, t is greater than or equal to negative 1. When I'm graphing, since t is less than or equal to negative 11 thirds, I have a bracket on negative 11 thirds and everything to the left. Since it's an or, it's okay that they don't overlap. T is greater than or equal to negative 1, so there is a bracket on negative 1 and pointing everything to the right. With interval notation, since this is an OR, it's a union, so I'm going to use a U. Parentheses, negative infinity, comma, negative 11 thirds, bracket. Union, a U, bracket, negative 1, comma, infinity, parenthesis. Yeah. 2 intervals since it's an OR. Alright, let's run through a problem pretty quickly here. A company that manufactures ink cartridges for printers finds that they can sell X cartridges a week at a price of P dollars for each. Now according to a formula, X equals 1300 minus 100P. What price should they charge for each cartridge if they want to sell at least 300 cartridges? At least means that it has to be greater than or equal to 300. Okay. So my X, which is the number of cartridges, is less than or equal to 300. So at least. That's not right. It should be greater than. I just said greater than and I didn't put greater than. Greater than or equal to 300. There we go. Okay. Since we already had an equation for X, I can replace X with 1300 minus 100P is greater than or equal to 300. Subtract 1300 from both sides. Now I get negative 100P is greater than or equal to negative 1000. Divide by a negative number. I have to flip the sign. So P is less than or equal to 10. So what does that mean? To sell at least 300 cartridges, the price should be less than or equal to 10, meaning no more than $10 per cartridge. Okay, let's try another equation there. Hopefully my mouth will work better. The formula F equals 9/5 C plus 32 gives a relationship with the temperatures of Fahrenheit and Celsius. So, if the temperature and a range for a certain day is 86 degrees to 104 degrees Fahrenheit, what would the range be for Celsius? Well, that means our range is 86 is less than or equal to F is less than or equal to 104, since we're all in Fahrenheit. But now I have this equation as to what F is. So I'm going to replace F with this equation. So 86 is less than or equal to 9/5 C plus 32 is less than or equal to 104. I'm going to go ahead and leave it in this format, but I have to remember whatever I do to the middle one, I have to do both to the left and the right to make everything balance. Subtract 32 from the middle, subtract 32 from the left, subtract 32 from the right. That will give me 54 is less than or equal to 9/5 C is less than or equal to 72. I don't want to know what 9/5 C are, I want to know what C is, so I'm going to multiply by the reciprocal. But not just to the middle one, to left and right and middle. So 9/5 times 54 is less than or equal to 9/5 times 5/9 times 54 for the left is less than or equal to 5/9 times 9/5 C for the middle, less than or equal to 5/9 times 72. That's going to give me 270 over 9 is less than or equal to C is less than or equal to 360 over 9. Divide everybody by 9. 30 is less than or equal to C is less than or equal to 40. So a temperature range of 86 degrees Fahrenheit to 104 degrees Fahrenheit corresponds with a temperature range of 30 degrees Celsius to 40 degrees Celsius. Kind of neat how we can do that all in one step. So I'm not going to blow smoke here. Working with compound inequalities takes a little bit of practice. So what I would do is run through each of these on your own, see if you can do them. The answers are right there, so you want to check your work. Otherwise, that's it for this lecture. Until next time, be seeing you.